Hello everyone, welcome back. Today we'll be finding, since this is a series of finding electric fields due to different charge distribution. So today we will be finding electric field and potential as well. Okay, electric field and potential due to charged conductor. Okay, due to a charged conductor. First we will take a finite length and then of infinite length. Okay, so we'll start. Suppose this is a conductor. Okay, having charge q, right? And we need to find electric field at this point. Okay, uh, from at this point due to this conductor which is charged. Okay, this is a point. Okay, it is not at a suppose its length is if its length is L, then it is not at the center. Okay, it can be anywhere. Okay, now what we do, join these 2 points. Okay, suppose these ends are making an angle theta 1 and theta 2. Okay, so since electric field is varying, okay, uh, along the length, as we move in this plane or in upward direction or in downward direction, electric field is varying. Okay, so we need to take a component. Okay, suppose dq here. Okay, dq of length dl. Okay, at a distance say x, at a distance of x. Okay, from this point. So what we see, and this distance is what, capital R. Okay, now if we join this, then according to Pythagoras theorem, what will be there? There will be, suppose this is a small r. Okay, then small r is equal to capital R square plus x square. Okay, now the electric field due to this element dq will be in this direction, right? It will be say d, and it will have what, two components. Okay, the first one is perpendicular, say it is d perpendicular, and this will be d cos theta. Okay, and this will be d sin theta. Okay, and we are taking this dq at a distance say x, and this angle is what, it is theta. Okay, we are taking the component at an angle theta with the horizontal. Okay, so this angle will also be theta, vertically opposite angle, and that's why these components are like this. Okay, now we define linear charge density as lambda dq by dx. Okay, or dq by dl. Say this is actually say dx. Okay, because terminologies will be more in more in synchronous. Okay, so now what will be d? D will be simply k dq square, sorry, k dq upon r square, right? And what will be e perpendicular? This one, it will be d perpendicular, you will integrate this d cos theta, right? And we have our d. Okay, so this will be e perpendicular is equals to k dq upon r square cos theta, right? Now we'll replace this dq, okay, this dq by lambda into dx we have defined here. Okay, so this will be k lambda dx cos theta upon what we'll write, we can write this small r square as capital R square plus x square, right? And we can also replace this cos theta as, you have to write the whole step, I am just removing it. Okay, just for the simplicity we can write this cos theta as what, capital R upon under root r square plus x square. You can see from this triangle. Okay, now we have simplified the equation. Okay, now e perpendicular will be, just take the commons out. Okay, k lambda into r dx upon r square plus x square power 3 by 2. Okay. Now from this triangle, we have what? We have another relation. Now from here you need to move here. Okay. We have another relation. Say this relation is actually x is equals to r tan theta, right? And we are going to use this equation. Okay. Now if you differentiate it, okay, with theta, then what we'll get? Dx by d theta is equals to r sec square theta, right? And dx will be what? It will be multiplied here, so it will be d theta, and I will remove this dx. Okay, so it will be something like this. Okay. Now you just need to put this in this equation. Okay, suppose this is equation 1. Okay, and you need to put the value of dx here. Okay, so E perpendicular will be what? It will be, and if you put the values, okay, k lambda r. Okay, so r sec square theta d theta upon r cube sec cube theta. Okay, moving on to the next page. E perpendicular will be, I'm just giving you the simplified equation, k into lambda divided by capital R. This integration will be somewhat like this, theta. Now what will be the variation of theta? Since theta is varying from where? From minus theta 1 to theta 2, right? Why we have taken minus? Because this theta 1 is in this direction and this theta 2 is in anti-clockwise direction, right? So we need to put the limit of theta, and theta is varying from where? From minus theta 1 to theta 2. Okay, we just need to integrate, and we'll get what? E perpendicular is equals to k lambda by r in bracket, after solving all these equations, okay, sine theta 1 plus sine theta 2. Okay, similarly I'm giving you just you can do it at your home as well. I'm giving you the task of finding E parallel. Similar way, you need to write d sine theta, then put the value of d, put the values of sine theta as well, and just use this relation. Okay, dx equal to r sec square theta d theta. Okay, and when you solve this, I'm just writing the answer so that you will be comfortable. E parallel will comes out to be k lambda by r mod of cos theta 1 minus cos theta 2. Okay, this will be the E parallel. So we have find the E perpendicular, we have finded the E parallel. So E net will be what? It will be root of E perpendicular ka square plus E parallel ka square, right? This will be the net electric field. Okay, and if the rod is of infinite length, we'll do different cases. Then theta 1 will be what? Tending to 90 degree, and theta 2 will be tending to 90 degree. Okay, then E parallel will be what? It will be 0, and E perpendicular will be 2k lambda by r. Okay, similarly you can do different cases when theta 1 is tending to 0, theta 2 is 90 degree, and likewise. Okay, now this is our first topic of finding electric field. Okay, now in the other video or in the same video, okay, we'll find the electric potential. Okay, in the other video we'll do so. Okay.